Hey guys, hey Red Devil Chemist, Coach Scott with another edition of Let's Work This Problem. So on this one, I'm looking at Worksheet 4E Problem 2. It's one of them I didn't tell you had to do, but I want to work it for you because some of you are motivated and might want to try it. So this could be considered a hard problem, but it really isn't. It's a combustion problem, but I don't have just two ingredients. I've got actually four, right? So I can find carbon and hydrogen. We know how to do that by using our combustion analysis. Nitrogen and oxygen, we really can't. Oh, but look, it gives us how many grams of CO2 we got. It gives us how many grams of water. So I can get the number of moles of carbon and the number of 0.18 grams. So now I can get the percentage of oxygen by doing this. All right, let's go ahead and do that first. Oxygen percent, all right, is 24.18 grams of oxygen divided by the total, 96.72 grams, okay, of the sample. By 100, we will get 25% oxygen. So let's get us a little table going. All right, because we know we can do carbon to to get our percentages, get the number of moles. So now let's work on the carbon and hydrogen. So it says the combustion of a compound contains only carbon, hydrogen, nitrogen yields 84.49 grams. Change that, 84 grams CO2. All right, and by doing that, all right, we're going to convert that into moles CO2, and the formula mass of that is 44.011 grams. All right, and that's going to give me 1.9197 moles of CO2. Now we know that for every mole of carbon dioxide, there is a mole of carbon. So that means in the sample there's 1.9197 moles of carbon. Okay, 1.917 moles of carbon. So let's go ahead and do the water. Okay, well, let's get the percentage. We're going to get grams, that's in there, so that's moles. And to get the atomic mass of carbon, we look on our periodic table. That's 12.011 grams of carbon in 1 mole. So that's going to give us our mass of carbon, which is 23.058 grams of carbon. So now if we divide that by the total, which is 49.14 grams of total, let's say total, that's going to give us the percentage times 100 of carbon. And if we do our math, we're going to get 46.92%. So now we can put that up here. So now all we've got to do is work on our hydrogen. Our next step is work on our hydrogen. And it says we have, let's change colors. It says we have 27.65 grams of water produced. So we're going to do the same thing to that, grams. Okay, and our molar mass of water is 18.0158 grams of water. And that's going to give us 1.5347 moles of water. And we know that if we have a mole of water, that for every 1 mole of water, we have 2 moles of hydrogen atoms, H2O. So if we multiply that by 2, that's going to give us our amount of hydrogen that came from the sample. Okay, and if I do that, I think my math is right. I get 3.0695 moles of hydrogen atoms. So now if I take 3.0695 moles of hydrogen, okay, and I convert that to a mass, all right, by multiplying by the atomic weight of hydrogen, that's going to give me my grams of hydrogen. 3.09377 grams hydrogen. Now if I divide by the total of the sample, 49.14, I'm going to say total, that'll give us our percentage of hydrogen. And it looks like that is 6.29%. Now let's look. We got 46.92% carbon, 6.29% hydrogen, 25% oxygen. I don't have my percent of nitrogen, but that's not too hard to get. Because now if I take 100 and I subtract the carbon, 21.79% nitrogen. So now we can do with what we know we've done in the past, we can set our table up, right? And if we set our table up, C, H, O, and N, we can assume we have 100 grams of sample because we've got all the percentages. So now we can find the empirical formula. Right, 46.92, hydrogen 6.29, oxygen 25%, nitrogen 21.79%. Okay, and we're going to assume that those are. Now, if we divide by the atomic masses of all these, 16.00, nitrogen 14.007. 91 moles, that's 46.92 divided by 12.011. We paused for something, but we're still good. Let's go. Okay, so let's see, 6.29 divided by 1.0079. I come up with 6.24. 25 divided by 16 is 1.56. 21.79 divided by 14.007, I get 1.56. So now if I divide through by the lowest number of moles, drop the pen, which would be 1.56. 1.56. Divide that by 1.56, 1.56. Draw a line. That's going to give me a 1. That's going to give me a 1. That's going to give me a 4. Bend this up a little bit. And that's going to give me 2.5. So I can't have 2.5. Whoops, sorry. So now if I multiply that through, everything through by 2, all right, that's going to give me 5 molecules or 5 moles. That's going to give me 8 moles of hydrogen, 2 moles of oxygen, 2 moles of nitrogen. So now let's write our formula out. All right. Use this one. So that's going to give me carbon 5, hydrogen 8, 2 oxygens, 2 nitrogens. That's my empirical formula. And that answers the problem. We're done. Okay, it is what it is. I have no idea what that YouTube is, but that's okay. So guys, that's the last one of the day. Got to work on your test. Red Devils, Red Devil Chemist, peace out.